Yellowstone National Park has been causing quite the stir lately. Between record-breaking floods, an earthquake swarm, and all the talk of a supervolcano eruption, it seems like Mother Nature is just itching to blow. But are these events really cause for concern, or are they just part of living with our planet's ever-changing temper tantrums? In this vein, there's a lot of chatter about Yellowstone's geysers, especially Old Faithful. It's all because they might have something to do with some pretty big events happening beneath the surface. Now, if you're watching this video, you're probably pretty interested in what happens at Yellowstone. So let's dive into the world of boiling water and geothermal wonders to see how they play into this larger story. Welcome to my channel. Yellowstone's geysers have long captured the imagination of park visitors and scientists alike. In fact, it was the world's first geyser to be officially discovered by non-indigenous people way back in 1870. Since then, it's continuously fascinated us with its powerful eruptions that shoot scalding hot water hundreds of feet up into the air. And we haven't even mentioned the smell of rotten eggs. Yep, that's right. The reason why is pretty fascinating. Geysers are some of the most dramatic features of Yellowstone's geothermal wonders. These spectacular fountains of hot water erupt from vents or openings in the Earth's surface. They come in a variety of shapes, sizes, and eruption frequencies. But the main ingredient that makes them go off is steam. When groundwater is heated by magma chambers, it turns into steam and forms pockets of pressure beneath the ground. As more water seeps into the ground and gets heated, the pressure rises until the force is strong enough to blast the water up through the vent and create that iconic geyser eruption. Now, the water doesn't just disappear after it erupts. No, sir. It collects in a basin at the base of the geyser and then trickles down into the porous rocks below. Eventually, this water makes its way back to the steamy depths where it gets heated up and starts the whole process over again. That's right, folks. A geyser is like a giant natural water recycling system powered by the heat of the Earth itself. But here's where things get interesting. Some of the water that feeds Yellowstone's geysers comes directly from rainfall and snowfall that lands on the park's rugged terrain. But a significant portion actually originates deep within the fractured and porous layers of rock beneath the surface. This hidden source of water is recharged by the very same precipitation that feeds the rivers and streams above. Over time, this water seeps deep into the ground, eventually making its way to the massive reservoir known as the aquifer. You can think of it like a giant underground lake filled with plenty of warm water ready to be blasted out of a geyser. So what does this have to do with earthquakes and volcanic activity? Well, the water that feeds Yellowstone's geysers doesn't just sit around doing nothing. Oh no. It's constantly moving and grooving through the rocky terrain, creating all sorts of fascinating interactions along the way. One of the most notable of these interactions occurs when the water seeps into the fractured rock layers and mixes with gases such as carbon dioxide and hydrogen sulfide. These gases, which are produced by the decay of organic matter and volcanic activity, react with the water to form weak acids. These acids then dissolve the rock, creating channels and pathways for the water to flow through. This process of water seeping into the rock, mixing with gases and dissolving the rock, is known as water-rock interaction, and it plays a crucial role in the formation and maintenance of Yellowstone's geysers. The water-rock interaction also contributes to the unique smell of sulfur that permeates the air around Yellowstone's geothermal areas. This is due to the release of hydrogen sulfide gas, which has a distinct rotten egg odor. However, the amount of hydrogen sulfide gas released during geyser eruptions is relatively small. So while you may notice the smell, it's not strong enough to pose a health risk to humans. Pretty cool, huh? Now, the water that feeds the geysers doesn't just dissolve rock. It can also carry dissolved minerals and other substances to the surface. These substances often precipitate out of the water once it reaches the surface, forming colorful mineral deposits such as silica, calcite, and iron oxide. These deposits can build up over time, creating stunning formations that are home to a variety of colorful bacteria. These bacteria use the minerals as food and convert them into forms that are more easily used by other organisms. The result is a vibrant ecosystem of microbes that contribute to the rich biodiversity of Yellowstone's geothermal areas. But perhaps the most fascinating aspect of Yellowstone's geysers is their ability to create entire ecosystems on the landscape. The water that erupts from these geysers is incredibly hot, reaching temperatures of up to 200 degrees Fahrenheit or 93 degrees Celsius. Despite this scorching heat, however, life finds a way to thrive in these environments. The hot water creates shallow pools of liquid that quickly cool down once they reach the surface. This creates a unique habitat that supports a variety of organisms, including algae, bacteria, fungi, and even some types of protozoa. These organisms form the basis of a food web that supports a variety of wildlife, including insects, fish, and mammals. For example, the protein and minerals in the water provide a rich source of nutrients for insects such as mayflies and stoneflies, which in turn provide food for birds of prey such as osprey and bald eagles. Larger animals such as bison and elk are also known to congregate near geyser basins, attracted by the lush vegetation and abundant wildlife. As you might have guessed, Yellowstone's geysers are not only a wonder to behold, but also a valuable resource for understanding the complex interactions between water, rock, and life on Earth. Okay, so now let's get into the nitty-gritty. What's all this got to do with the recent earthquakes and volcanic rumblings? You see, since the beginning of 2022, Yellowstone's geysers have been behaving a little strangely. Some have been erupting more frequently than usual, while others have seen their eruption strength increase. Take the Upper Geyser Basin, for instance. It's home to more than 100 geysers, including the famous Old Faithful. In recent years, scientists have noticed that the number of geysers erupting in this area has increased by almost 50%. And that's not just a random observation. In addition to the increase in the number of erupting geysers, some have also seen an increase in eruption vigor. That means they're not just erupting more often, but also with more force. For example, the geyser known as Castle, which normally erupts every 90 minutes, suddenly began erupting every 12 minutes. To put that in perspective, Castle's regular eruption interval was already shorter than the average for Yellowstone's geysers. But this sudden change in behavior is still remarkable. Now you might be wondering, why should I care about the eruption habits of a couple of geysers? Well, here's the thing. Geysers are like the canary in the coal mine when it comes to detecting changes in the behavior of a volcano. See, Yellowstone is a supervolcano, meaning it has the potential to erupt with incredible force, unleashing massive amounts of ash and lava that could cover vast swaths of the United States. While a super eruption is a rare event that occurs only a few times per year, Yellowstone has been showing some signs of unrest in recent years. Scientists have detected an increase in seismic activity in the region, as well as changes in the patterns of ground deformation. These changes could indicate that magma is moving beneath the surface, which could eventually lead to an eruption. And geysers like Castle can give us an early warning sign that something is brewing beneath the surface. For example, in the weeks leading up to the 1985 eruption of Nevado del Ruiz in Colombia, scientists observed an increase in the frequency and intensity of eruptions at nearby hot springs and geysers. Similarly, before the 1991 eruption of Mount Pinatubo in the Philippines, scientists saw an increase in the amount of gas being released from volcanic vents, as well as an increase in the number of small earthquakes in the region. By monitoring changes in geyser activity, scientists can potentially detect changes in the behavior of the volcano and better predict the likelihood of an eruption. Now, it's important to note that an increase in geyser activity is not necessarily a sign that an eruption is imminent. More research is needed to fully understand the relationship between geyser activity and volcanic unrest at Yellowstone. But it's still an important piece of data for scientists to consider as they monitor the volcano's behavior. So while a super eruption at Yellowstone is still considered unlikely, scientists are taking all possible measures to monitor the situation closely. And who knows, maybe the next time you visit Yellowstone, you'll witness a rare and awe-inspiring event that helps us better understand our planet's inner workings. Just remember to keep an eye on those geysers, and don't forget to stay humble in the face of nature's awesome power. After all, We're just tiny humans trying to understand the incredible forces that shape our world. Thank you for watching this episode. If you enjoyed it, please hit the like button and subscribe for more content. Your support means everything to us, and we'll see you